Alrighty, folks. Today we are going to begin our discussion about work power and simple machines and energy by beginning with work, or as Rihanna says, work, 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 work. I know she does it better, but that's okay. Alrighty, so our learning target for today is I can define work, identify when a force does work on an object, and determine the amount of work done on an object. So, with that being said, here is our agenda. If you have not yet, we have an attendance question for today since it's the first day of the unit. So maybe pause this video and just real quick go over to our Schoology page and answer the question, what do you know about simple machines? This is your attendance for today. After that, I want you to go ahead and set up your notes. Our topic is work, and our essential question is, how do you determine when and how much work was done? After that, we're going to take notes. After you're done with notes, there is some math involved, so I have some math tutorials posted for you that you can check out if you need some help. Otherwise, you can move on to do the math practice and check your answers on the key. So go ahead and make sure that you have completed the attendance question and have your notes set up, and then we are going to go ahead and get started. All right, let's go ahead and start off with defining what work is and how to identify work. So, work is a force that acts on an object in the direction the object moves. All right, so that is our definition of work. So you actually have to have two things in order to have work. Number one, you have to have a force and you have to have movement. Those two things both have to be present. If you don't have any force or if you don't have any movement in the object, then no matter how much force is on it, there is no work being done. So, a couple of examples of work actually happening. If you have a kid pushing a lawnmower, that is work because the kid is exerting a force on the lawnmower and the lawnmower is moving, therefore work. An engine driving a car down the road. The engine is exerting a force on the car and the car is moving down the road, therefore you have a force and movement, therefore you have work. Horse pulling a plow, you see that image right here. The horse is exerting a force, on the plow, and the plow is moving, therefore work is being done. And if you just drop a ball from a ledge, in that case, gravity is a force acting on the ball, and the ball is moving, therefore work is being done. However, work is not happening in the following situations. A bookshelf holding books. While the books are exerting a downward force on the bookshelf is not moving, therefore there is no work being done. A student standing still with a backpack on. If you're ever doing this, you're actually not doing any work because even though the backpack has a downward force and you feel that weight, you are not moving the backpack, therefore no work is being done. A truck sitting at a stoplight with a big rock in the back. So even though that truck is sitting there and the truck has an engine in it and there's a big rock pushing down in the back, all those things with forces all around, the truck is not moving. Therefore, there is no work being done. So that's the thing that we're really going to focus on here, is that in order for work to be done, you have to have a force acting on an object in the direction that object moves. What question does the previous slide answer? All right, so let's go ahead and identify work in action. So work requires motion. So what do you do if you have a force but no motion? So if you have a force but no motion, then no work is being done. Yes, the force is exerting on an object, but there is no work being done. So let's take a look here at this weightlifter. So you see there's a couple of parts to him doing this weightlifting. There's him actually lifting it up, which we'll see in a second here. So lift it up, and then he holds it, and then he drops it. Okay? So there's a couple of times that work is being done on the weights there. So as the weights are moving up, work is being done because the weightlifter is exerting a force in the direction that the weights are moving. However, right here where he's holding it and it's not moving, that means no work is being done, right here. That is because even though there is a downward force being exerted on the weight is not moving and therefore no work is being done. Then after he holds it for a second, he drops it right there. The force of gravity is causing the dumbbells to move, or the barbell to move downwards, and the fact that you have a force, gravity pushing down, and the barbell is moving down, that means that work is being done on the barbell. So for a force to do work on an object, some of the force must act in the same direction as the object moves. If there is no movement, no work is done. So work is done when an object is pushed or pulled. Okay, so that actual application of the force and causing the movement. So we're combining force and movement that we learned about from last unit. All right, so I've got a little image right here, and we see SpongeBob right here, and he's doing some training with some stuffed animals on his barbell. And then we have this super beefy unicorn, and this unicorn is holding up a barbell. So the question becomes, who is working harder in this situation? Is it SpongeBob or is it the unicorn? So even though the unicorn has a lot more weight on its barbell and you can see the unicorn is struggling mightily, the fact of the matter is SpongeBob is doing more work because SpongeBob is actually moving the object. So he is exerting a force that is causing that barbell to move up and down. And so because there is force and motion, that means that SpongeBob is working harder. Even though there is more downward force on this barbell that the unicorn is holding, there is no motion, and therefore there is no work being done by the unicorn. What question do the previous slides answer? All right, so all of this is to say we actually have a way to calculate work, because as we've said, work involves both force and distance. And so therefore, we have an equation. Work equals force times distance. And very nicely, this equation fits into our formula triangle model. So please feel free to create a formula triangle for work. So here's what we need to know. If work equals force times distance, as the force increases, the work increases. That would make sense because of how the equation is set up. If you have more force, that means that work is going to go up since force is a multiplier. As distance increases, the work increases. So the more distance an object moves, the more work it requires. So think about this. Let's just say that you have a brick laying on the ground and you're going to push that brick. So if you push that brick 1 meter versus 2 meters, the 2 meters, or when you push that brick 2 meters, that means that you did more work. Also, if you just very gently push the brick, that's not much force, but then if you really hit the brick hard, that's a lot more force, and so you did more work when you hit the brick hard. All right, so force equals newtons. We know that from Newton's second law. So we measure force in newtons, and distance is measured in meters. So work equals the unit of newtons times meters, and those units actually combine to create a unit called joules. So we measure work in joules, and you are expected to express your answer for any work problem in joules. Newton meters is not a correct unit. You need to use the simplified unit of joules. And maybe this will help you remember it, but you have to do your work to get your joules. What question does the previous slide answer? All right, let's do a quick practice problem. And this is actually on your practice sheet. So if you turn into your packet, you will find a worksheet on work. All right, calculate the work done by a 47 Newton force pushing a pencil 0.26 meters. All right, so we have our force of 47 newtons. We have the distance that the pencil was pushed, which is 0.26 meters. Using our formula triangle, or that means that we're calculating for work. Then using our formula triangle, we cover up work, and we see force and distance are next to each other. Therefore, we are multiplying. Work equals force times distance. We go ahead and plug in the numbers we have. 47 newtons for force, 0.26 meters for distance. 47 times 0.26 is 12.22. Newtons times meters combines to Newton meters, and remember, we need to simplify that to joules. So the work done was 12.22 joules. Alrighty, so that's how you do that problem. So what question does the previous slide answer? All right, now before we finish up here, I want you to take a moment and I want you to try to solve questions 7 and 8 on that same worksheet, okay? So question 7, a crane uses a force of 5,200 newtons to lift a girder 25 meters. How much work does the crane do on the girder? Question 8, a man does 2,100 joules of work while exerting a force of 700 newtons on a refrigerator. How far did the man push the refrigerator? I want you to go ahead and pause this video, and I want you to try to work these problems out and see the number you get, okay? I'm then going to share the answer with you in just a moment, and we'll use that to help figure out where you are at in terms of your understanding. All right, so for question 7, you should have gotten 130,000 joules, and for question 8, you should have gotten 3 meters. So if you got those questions right, that's awesome. That means that you're ready to do more practice. If you struggled with those questions and you did not get the correct answer, what I'm going to ask you to do is after you finish this video, head over to the tutorials folder in Schoology, and you will see a video of me working through these problems and showing you how to solve them. Alrighty, folks. I want you to go ahead and self-assess on a scale of 1 to 5. How well do you understand work? 1 is super confused. 5 is I've got this. All right, time to do your worksheet. Get it? Oh man, that's funny. All right, so based on how you rated yourself, here's how I want you to work or do your worksheet. If you rated yourself as a 1 or 2, I want you to make sure you're watching those video tutorials I posted on how to do the math, and I want you to set up an office hours appointment with me. That way I can kind of answer any questions you have. Maybe we can work through some more questions together. If you scored between 3 and, or if you say, assess yourself at 3 to 5, I want you to do some problems on the worksheet and check your answers on the key. If you're getting all of them right, great. That means that you're ready for the quick quiz. If you're still struggling a little bit, maybe check out those video tutorials and do some more practice. But do as much practice as you need to in order to be successful. Alrighty, folks, have a great day.